Assalamu alaikum and good morning everyone. This is Sayyid Anas Gilani here and I am going to give an overview of chapter 0 in our microcontrollers. So, in chapter 0 we have different topics which include internal organization of computers, the different parts of computers, IO, memory, CPU, connecting the different parts, connecting memory to CPU, connecting IOs to CPU, how computer works. Internal organization of computers. CPU, memory, I/O. Input, example, keyboard, mouse, sensor. These are the inputs. Outputs, example, LCD, printer, hands of a robot. These are all outputs. Memory, everything that can store, retain, everything which can be stored, it is included in memory storage. Memory characteristics, capacity, the number of bits that a memory can store. Example, 128 kilobits, 256 megabits. And organization, how the locations are organized. Example, a 128 into 4 memory has 128 locations bit each. Access time, how long access time includes how long it takes to get data from the memory. These are semiconductors, and these are some images of the semiconductors. These are non-semiconductors, semiconductor memories. ROM, mask ROM, ROM random read only memory. PRO, programmable ROM, erasable ROM, electronic erasable ROM, flash, electronic programmable ROM. And these are the RAM, programmed by IC manufacturer. Program ROM, OTP, one time programmable. You can program it only once. EPROM, erasable programmable ROM, UVEPROM. So erased electrically. This is the block diagram, which includes this VOC, VC, WE, NC, AB, AN, part, and so on. Each byte can be erased separately. Memory ROM and flash ROM. Erased in a flash. The entire device is erased at once. These are part numbers. This is the capacity. This is ORG, speed, pins, VPP. Semiconductor memories, ROM, mask, etc. DRAM, dynamic RAM. RAM means read only, random access memory, made of capacitor. There are some advantages of DRAM: less power consumption, cheaper, high capacity. Disadvantages include slower and refresh needed. NVRAM, non-volatile RAM, made of SRAM, battery control circuitry. Advantages: very fast, infinite program erase cycle. Non-volatile. Disadvantages include expensive. eh, Expensive. It is expensive. Internal part of computer CPU. Task: it should execute instructions. It should recall the instructions one after another and execute them. Connecting memory to CPU. Memory pin out. This is something reading from memory. This is the CPU block diagram connecting to IOs to CPU. CPU should have lots of pins: CPU, network, mouse, keyboard, sound card, graphic card. Connecting IOs to CPU using bus. Do. Address bus, data bus, control bus. This CPU is connected to the address bus, which is connected to then this database, and the control bus write read. A control bus is used for write read. Connecting IOs and memory to CPU. Address bus, data bus, control bus, and this is a similar CMU. Connecting IOs and memory to CPU using bus. How could we manage it? Address bus, data bus, and this is the control bus, and the IO 0, IO is 1 here, IO is 2, IO n, till how much it goes. Connecting IOs and memory to CPU using bus. Peripheral IO. This is the peripheral IO, which is ground, VCC, AD, DO0, DO, D7, WE, OE, CS. And this is a similar IO0 and which are connected to those. Connecting IOs and memory to CPUs using bus memory mapped IO. How could we make the logic circuit? Address bus. Solution: write the address range in binary. Separate the fixed part of address using a NAND design. A logic circuit whose output activates when the fixed address is given to it. From 0 to address 15 0 0 0 0 1 1 1 1. Decimal to binary conversion. Example 0 to 1. Convert 25 to the base 10 to binary. 25 to 12, 12 to 6, 6 to 3, 3 to 1, 1 to 0. It is the quotients, these are the remainders. Like 25 to 12, we have one remainder as 12 to 0, 6 to 0, 3 to 1, 1 to 1. Binary to decimal conversion. Example, convert 11011 to the base 2 to decimal. Like here is the weight, the digits, sum, and is equal to 25 to the base 10, 16, 8, 4, 2, 1. Similarly, it's the example 3. Hexadecimal system. Representing binary 1001111110101 in hexa. Solution. The first number is grouped into set of 4 bits like 1001, then 1111, then 0101. Then each group of 4 bits is replaced with its hexa equivalent. Like 1101 is 9, 111 is F as it's above 1111, and 0101 is 5. Therefore, 10011110101 to the base 2 is equal to 9 F5 hexadecimal. Convert hexa to 9B to binary. Solution to 9B. 2 is 0010, 9 is 1001, B is 1011. Now decimal to hexa conversion. Convert 45 to the base 10 to hexa. 32, 16, 8. First convert to binary. 32 plus 8 plus 4 is equal to 45. 45 to the base 10, 00101101 to the base 2 is equal to 2D hexadecimal. Similarly, we'll do the conversion of 629 to the base 10 to hexadecimal, and then the conversion of 1714 to the base 10 to hexadecimal. Now it's hexa to decimal conversion. 6B to 16 is equal to 01101011010 to the base 2. How it comes? 1024 is 1, 512 is 1, 256 is 0, 121, 640, 321, 161, 80, 40, 2110. And when we add them, we get 1714 to the base 10. Then this is the addition of the binary 110. Like if we have 1101 and plus 1001, we'll get 0. Like 110 and 1, 1 comes carry here, and then 110 is 1, 11 is 01. To the decimal, 13 plus 9 is equal to 22, and if we get it to the decimal, we'll get 22. And this is a short table for the basic binary digits. We can multiply revise them. Another example for address decoder. Design an address for decoder. Design an address decoder for address of 300H to 3FFH. Now for 300H, take the first 4 digits 0011, then 000, then 000, and for similar 3FFH 0011 111 111. An easy way of designing. It's an easy way of designing. Inside the CPU, PC program counter. Inside the CPU, we have a program counter. Then instruction decoder. Program counter gives the flow of current in it, or ALU arithmetic logic unit, which perform arithmetic operations in ALU registers, and then the registers. How computer works. Address bus IO16, IO17, IO18, ION. How computer works. This is the same we have discussed before. It is the address bus, data bus, control bus, read and write. Data bus store the data, address bus store the address of the data. This is ALU, where arithmetic logical operations are performed. This is a program counter, like 5 times the program will run, and inside there. How instruction decoder works. This is the instruction decoder, OP code, operand, and then operation code 000A, 001, AX, and this is similarly the all next will go. General purpose microprocessors versus microcontrollers. Microprocessors. No RAM, ROM, IO ports on chip itself. Example, Pentium, Intel. PowerPC, Motorola, Spark, Sun. Applications. Applications for microprocessors are desktops, laptops, workstations, and servers. Microcontrollers include microprocessors, RAM, ROM, timers, IO pods on a single chip. Like microcontroller is a huge range of different small computers, which includes microprocessor. General purpose microcontroller versus microprocessors. Purpose microprocessor. This is connected data bus through RAM, ROM, timer, serial comport, IO port. Embedded systems. An embedded system is controlled by its own internal microprocessor or microcontroller as opposed to an external controller. A PC is connected to various embedded products such as keyboard, printer, modem, disk, control, sound card, CD-ROM, driver, mouse, and so on. A printer gets data and prints it. A mouse takes coordinates and sends to the PC. Embedded products. Computing PC node computings. These are the cars. These are communication. These are the cards. Similarly, consumers and the connectivities using a microcontroller. We should check the speed, packaging, power consumption, amount of RAM ROM, the number of timers and IO pins on chip, cost per unit, availability of compilers, stimulator or debugger, availability of chip in market, the AVR microcontroller family. The basic architecture of AVR was designed by two students of Institute of Technology NTH, ALF, Igil Bojan and Vigard Volan, and then was bought and developed by Atmel in 1996. RISC and RISC and CISC. Complex instruction set computers, reduced instruction set computers. These are the types of complex instruction set computers. A large number of instructions, typically from 100 to 250 instructions, and this is relatively few instructions, have few instructions. Harvard and non-Neumann architecture. Von Neumann Princeton architecture. The same bus is used for accessing both the code and data. Hardware architecture. Separate buses are used for accessing the code and data memory. A set of data buses for carrying data into and out of the CPU. A set of addresses buses for accessing the data. A set of data buses for carrying code into the CPU, and etc. This is the AVR microcontroller family block diagram. The AVR family 32-bit AVR, X mega AVR, and here the chapter ends. Thank you for watching this video. Don't forget to like and subscribe.